Hi guys, and welcome to another video. Today we're going to be looking at finding the derivative using the rule. So the first thing that we want to look at is the notations for differentiation, and the notations are as follows: f prime x, dy dx, and capital D subscript x. When you see that, means that we want to find the derivative with respect to x. You can find the derivative of any expression with regard to any variable. So you could even find, for example, ds dt, where s, let's say, represents speed and t is time. So be the derivative of speed with respect to time. Okay, so you can have dv dt, derivative of volume with respect to time. It just means that now you must find the derivative with respect to that particular variable. The derivative of a constant is 0. Now, these are the rules that we need to adhere to. The derivative of a constant is 0. This is the rule that we need to know. If f of x equals to k x to the n, then f prime x is equal to k n x to the n minus 1. So all you do is you take this n over here, multiply k, the constant or the coefficient of x, and you subtract 1 from your exponent. But you must make sure that your expression is in the form kx to the n. Therefore, you must adhere to the following rules. All terms must be separate. Therefore, remove all brackets. So you need to, like, for example, be able to square a binomial. Remove brackets. No x terms in the denominator. Therefore, use the rule 1 over x equals to x to the minus 1. So you must be able to know this rule over here as well. Okay, so there mustn't be any x term in the denominator. No roots. Therefore, you need to know this rule. The nth root of x to the m is equal to x to the m over n. Factorize if possible. So you need to know all your factorization, like difference of 2 squares, sum and difference of 2 cubes, and so on and so forth. And if possible, or we must be able to divide by a monomial. And we're going to be covering examples of this nature in this particular video. Let's look at the first example. Okay, so here we're going to be looking at evaluate dy dx if y equals to x to the minus 4 plus 2x cubed minus x over 5. So the first thing that we have to look at, x to the minus 4 plus 2x cubed minus x over 5. So we have to see now whether every term is basically written as kx to the n. So here we got kx to the n. This term is fine. X to the minus 4. This term is fine. Plus 2x cubed. This term, I just want to write it as minus 1 over 5 times x, kx to the n. Okay, so just a slight adjustment there. Therefore, dy dx, the derivative of function y with respect to x, so the derivative of y with respect to x will be, let's follow the rule, minus 4x. Minus 4 times 1 is minus 4. X to the minus 4 minus 1. So you subtract 1 from there, you'll get minus 5. 3 times 2 is plus 6x squared. You subtract 1 from there, you get x squared, or x to the power 2. 1 times minus 1 over 5 is minus 1 over 5. Subtract 1 from here, you'll be left with x to the 1 minus 1, which is x to the 0, which is equal to 1. So that's why if you have a derivative of x, you're left with 1. Okay? If it was a derivative of minus 2x, you'll be left with minus 2. Okay? So this is our solution, and this is good enough. We can leave it like that. Okay? Now let's look at the next example. Find the derivative with respect to x. This is now going to equal to, let's see. Here we got 4. That's a constant, so that's fine. See here you got the x cubed in the denominator, so it's going to be minus 4x to the minus 3. And here you got x to the 4 in the denominator, so it will be minus x to the minus 4. Okay. So therefore, the derivative now will equals to, the derivative of a constant is 0. So this one here, this term disappears, 0. Okay, so we won't strike it off, we'll just leave it like that. Minus 3 times minus 4 is positive 12. X, now I'm going to be x here. Minus 3 minus 1 is minus 4. So I'm subtracting 1. Alright? Minus 4 times minus 1 is positive 4x to the minus 5. Remember? Minus 4, you're subtracting 1. Minus 4 minus 1 is minus 5. That's my answer. Okay? Next question. Here I got g of x, given g of x equals to x squared plus x minus 2 all over 1 minus x. Calculate g prime x for x not equal to 1. X can't equal to 1 because remember 1 minus 1 is 0. This function or this expression will be undefined. So let's factorize this top here. So we're going to be left with, remember now that's a quadratic. So x times x will give us x squared. 2 is a prime number, so 1 times 2 is 2. And here it's plus x, so that's going to be plus 2 and minus 1. Okay? Now what do we have here in the bottom? 1 minus x. So therefore it will be minus into x minus. Change of sign rule. Okay? So you just swap the two terms around, take on a minus sign. X minus 1 cancels. So what are we left with? Minus into x plus 2, which is equal to minus x minus 2. Therefore, g prime x will equals to, what's the derivative of minus x? It will be minus 1, and the derivative of a constant is 0. So your answer, g prime x equals to negative 1. So therefore, for this particular function, you're going to get a constant gradient. Okay, the gradient will be constant throughout. So it's saying here, explain why it's not possible to determine g prime 1. Well, here we're not going to get a gradient at a point, so our gradient is going to be constant. Okay, so we're going to get a constant gradient of minus 1 throughout. Okay, so it's not possible for us to get g prime 1 because we don't have any variables, we don't have any x terms, okay, for us to substitute. Now, in this next question here, we got evaluate dx. So here we got x cubed minus 3 all squared. So we're going to get x cubed, so we have to open out these brackets over here, right, according to the rules. So that will be x cubed minus 3 times x cubed minus 3 equals to, so a binomial times a binomial. Now there's two ways to do this. We can do this if we use the rules, square the first term, take the first term times the second term times 2, and then obviously square the last term. Okay, so you can use the rule, square the first term times second term times 2, or square the second term. Or you can just expand and do it like this. Use the FOIL method. X cubed times x cubed is x to the 6. 3 plus 3 is 6. Remember, when you multiply common bases, you add the indices. Then you get minus 3 x cubed. X cubed times minus 3 is minus 3x cubed. And here, minus 3 times x cubed is minus 3x cubed. And minus 3 times minus 3 is positive 9. Equals to, you're going to get x to the power 6 minus 6x cubed. I'm adding these two like terms here. And then plus 9. Okay, so even if we had to use the rule, square the first term, x cubed all squared will equals to, remember that's cubed, 3 times 2 is 6, so that's how you'll be x to the 6. First term times second term. Minus 3 is minus 3x cubed times 2 is minus 6x cubed. Alright, and then square the last term. Minus 3 all squared is equal to plus 9. Okay, so you can use the square the first term, double the product, and square the last term to square the binomial. Therefore, dx equals 2. So here we're going to get 6x to the power 5 minus 3 times minus 6 is minus 18x squared, and remember the derivative of a constant is 0. 6 times 1 here is 6, subtract 1, 6 minus 1 is 5, and 3 times minus 6 is minus 18, subtract 1 from 3, you get 2. That's the derivative. Let's look at this question number 5. Here we got find dy dx if y equals to 4 over root x square root of x minus x cubed over 9. So let's see now. So we got the root in the denominator, we need to get rid of it. So it will be 4 over x to the half minus x cubed over 9. And that's equal to 4x to the minus half. So we're going to take this x to the half here to the top. And remember the rule that I discussed earlier. And here we got minus 1 over 9x cubed. Now this is important because remember every term has to be in the form f of x equals to kx to the n before we can find the derivative f prime x equals to k times n times x to the n minus 1. So remember that my goal at first is to make every term kx to the n. Then it becomes easy for me. So therefore I can now say dy dx equals to half times minus 4 is minus 2, x minus half minus 1. Minus half minus 1 will be minus 3 over 2. Minus half minus 1 equals to minus half minus 2 over 2, which is minus 3 over 2. Okay? 3 times 1 over 9 is minus 3 over 9, which is equal to minus 1 over 3. So that's minus 1 over 3. X, 3 minus 1 is squared. So that should do it there. Okay? Now, next question, 6. Determine dy dx. Find the derivative of the function y with respect to x. So this will equal to 1 plus root x all squared. Once again, we can expand 1 plus root x, 1 plus square root of x all squared, or you can use a rule. 1 times 1 is 1, 1 times plus root x is plus root x times plus 1 is plus square root of x, and square root of x times square root of x is plus x, which is equal to 1 plus 2 root x plus x, which is equal to 1 plus 2x to the half plus x. Okay, so now we can say therefore dy dx equals to the derivative of a constant is 0. Half times 2 is 1, so you'll be left with x. Half times 2 is 1, so you'll be left with x, and half minus 1, you're subtracting 1 from here, will be minus half. And the derivative of plus x will be plus 1. Okay, remember derivative of a constant is 0. And over here, half times 2 is 1, and subtract 1 from here. Half minus 1 is minus half. The derivative of plus x is plus 1. Okay, and now this brings us to example number 7 to conclude this lesson. So here we got 2 root x, so that will be 2 root x. And remember this is a monomial denominator, so we want to divide 2 root x over square root of x minus 5x squared over the square root of x equals 2. So when you got a monomial, this is a monomial denominator. We take each term in our numerator and divide it by our monomial denominator. So root x and root x cancel, so we're left with 2 minus 5x squared over x to the half, which is equal to 2 minus, so here you got 5, here we got 2 minus half, because remember these exponents here, so that will be x to the 2 minus half. So 2 minus half equals to 4 over 2 minus 1 over 2, and that's equal to 3 over 2. So you'll be left with 3 over 2. Of course, you can use your calculator for fractions, but as you can see, there is no need to. Okay, so therefore, dy dx, derivative of a constant is 0. 3 over 2 times minus 5, so 3 over 2 times 5 over 1, that's equal to 15 over 2. So that'll be minus 15 over 2 x. There we got 3 over 2, so that'll be subtract 1. 3 over 2 minus 1 is equal to 3 over 2 minus 2 over 2, which is equal to half. So that will leave us with half. Okay, and that is our solution. Minus 15 over 2 x to the half. Right. So learners, that brings us to the end of this lesson, finding the derivative using the rule. Okay, remember to adhere to the rules that I've mentioned in the beginning of this particular lesson. There's the rules here. Remember to try and answer the questions and then go and check whether your answers are correct. If you haven't subscribed already, don't forget to subscribe to my YouTube channel. Check out all the videos on jlmaths.com. And I'll catch you in the next video.